Hey everyone, it's Mike. We are now heading into our last unit, power factor. I want to start off with the most basic, introduce you to some new formulas, and pictorially, or if we draw the power factor triangle, what that would look like and how it would represent a circuit. So the power factor formulas, I'm sure you guys have heard of VA before. So VA is your volts times amps. It's your actual volts you're putting into the circuit, and then the actual amps that you're drawing from the circuit, as in I put an amp probe around say the wire or the conductor leaving the breaker. So it's those volts times those amps, and that would be our VA. And another way we can interpret VA is it's apparent power. So it's the total power used by the circuit. But it's not say for a motor, it's not, necessarily the nameplate information on the motor, but we always require more power in than what the power is we're actually getting out. And when we talk about getting power out, that's our real actual power. Those are watts. So if I'm running a factory, I want the hydro I'm paying for, I want my apparent power to be as close to my actual power as possible so that I am minimizing my waste and I'm saving money. So leading up to this, we've done inductive loads, capacitive loads. Level 1, you did purely resistive loads. So anything that's inductive is going to, there's going to be some wasted power there because of what has to happen for that motor to turn is induction, induced voltages, a lot of copper losses. Motors have bearings and whatnot, and we have some loss. Same as a car. If you have a 300 horsepower car at your wheels, you're probably measuring, say 220 horsepower. So there's 80 horsepower that you lost from the engine back to the rear wheels. So we could comparatively compare it to that. Also, if not to sit here and encourage drinking beer, but if you get a beer poured out of a tap, the top inch of that beer might be all foam. When the foam dies down, you're left with your actual amount of beer, but the glass might have been a 20-ounce glass, so maybe there's only 18 ounces of actual beer in it. So you paid for 2 ounces that you didn't actually receive. So that's what we're talking about. When we're talking about power, VA. Now VARs is volts, amps, reactive. That's the difference between your VA and your watts, but it's not just a straight up VA minus watts. Don't forget we're dealing with phase angles here. So VARs is the difference after we've calculated our VA and watts. And again, we're just looking at a right angle triangle, so Pythagorean theorem can be used to calculate all the sides of this. And or if we don't have the sides but we have some angles, we're going to use SOHCAHTOA, which we've been doing all the way through. Now we look at the triangle. The hypotenuse is always going to be the VA. And then you can have your opposite side and your adjacent side, watts and VARs. When we're introducing capacitors into a circuit, we're measuring the capacitor by the amount of VARs. Okay? And we'll look at that in some future questions. Now I'm going to erase some of these formulas and add some more formulas up for you, and I'll post formulas on Econestoka for you in a Word document.